Good morning, my dear friends. Welcome back, all of you. I believe all of you have come prepared today also for another intense session of solving of the question bank. So yesterday, as most of us were there, yesterday we finished up the 4-mark questions. So today we'll focus on the 6-mark questions from the question bank again. So I believe you have your copy, your notebook, everything with it. So with you. So without wasting much time, let's go straight to the point. That is, let's begin straight with the question set. So the first question that is given to us is from sets, chapter 1. So these are the 6-mark questions. So I haven't written down the question because I believe you may have the copy. So let's go straight to the question. That is question number 1 in sets. These are of 6-mark questions. So the universal set is given to us 1, 2, 3, 4, 5, 6, 7, 8, 9. The sets A, B, C are also given. So we are just to verify some of the operations that is given to us here. So alright then, so let's just begin. Now, before we really go for the verification, let's try to get some of the values which we may need. So let's see what will be A union B. So A union B, let's try to combine. So that's going to be 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. A complement 2, 4, 6, 8. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. B complement, these values might help us, even just calculating in advance. B complement. So B complement will be 2, 3, 5, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course C complement, if we need 1, 2, 3, 4, 5, 6. I think that's all right. So A complement 1, 3, 5, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So now let's go for A union B. And of course A, okay, those values we'll find out. Now, if you look at the solution that is being done for you there. So A union B complement will be what? A union B complement. So all the values which are not in the set A union B. So 1, 2, 1 and 9. I think that's fine. And A complement intersection B complement. So A complement intersection common elements. We have 1, 1, 9. 1 and 9 again. So that means A union B complement is equal to A complement intersection B complement. So that's the verification here. We'll go to the next one. Second one. We have to prove A intersection B complement is equal to A complement union B complement. Fine. I think this is done. Alright, A intersection B complement. Alright, then this one I'll just do. A intersection B complement. So that is A intersection B. What do we have? A intersection B, we have 2, 3, 5. I think that's all, isn't it? Only 2. Right. So its complement. So then it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then similarly A complement union B complement. That will be A complement union B complement 1, 3, 4, 5, 6, 7, 8, 9. These are easy questions. So therefore A intersection B complement will be equal to A complement union B complement. Hence the verification. Simple as that. Simple questions, all this. Done? Okay, let's go to the last one. The third one is about A intersection B union C. I'll just go for the proof straight away. Okay, let me just write down. Should be equal to A intersection B union A intersection C. Alright. So let's get this. A intersection B union C. So A intersection, alright, B union C will be B union C. 2, 3, 5, 7, 8, 9. A intersection. So our set A is 2, 4, 6, 8. Okay, I wish 2, 4, 6, 8 intersection 2, 3, 5, 7, 8, 9. So the value will be intersection common element. We have 2 and 8. 2 and 8. So alright, that's done. I'll just go to the other side. And the other value, that is A intersection B union A intersection C. Alright, A intersection B. A and B, we have 2, 3, 4, we don't have anything else. Union A intersection C. A and C. A, C, A, C. What do we have in common? 8. So this is the union of it. So 2, 8. So as you can see, the verification is already done. So I guess that last line you can also write down, no? The verification line. Done? Alright, moving on to the second option, number 1B. Okay, these questions can be done. Good morning, good morning. Good morning, Aman. This question, the second question, that is number B, can be done, of course, in 2, 3 different ways. So I prefer the send up good morning. I prefer the usual way. Okay, I prefer another way. So everyone has their own likings, as I say, no? So that can vary. So here what I'll do is I will solve this using Venn diagrams. So in a group of athletic teams, I believe all of you have the question paper, so I'm just reading it. Athletic teams of a public school in New Delhi, 18 are in basketball, 12 are in cricket, 22 are in football team. 22 are in football team. Good morning, all of you. If 9 play basketball, cricket, 10 play cricket, football, 8 play football, basketball, find the number of this and that, this and that. Alright, so what I'll do here is, I will take the help of a Venn diagram. This way, it's also easy. So I'll consider these 3 sets. So maybe the first set. So we have here 3 sets of students playing basketball, cricket and football. So I'll just write as per the letters, that will be easy for us. Basketball, cricket, football. And then I'll use some letters within the bounded regions. That is letter A, B, C, D, E, F and G. So let me just explain. So let B, C and F denote, this is a very simple question, okay? Denote the set of players, let's say. Denote the set of players who play basketball, cricket, and football. And the letters A, B, C, D, E, F, G denote the values, let's just say, denote the values or elements in the bounded regions. This is a very easy way to solve, okay, Venn diagrams. You will be able to solve any sort of questions once this is sorted out, and then it doesn't require much calculation also. Very simple. Alright, okay, so I'll be rubbing this off now. So then as per the question, what we have is 18 are in the basketball team. So you can see that 18 are in the basketball team. So who are the players in the basketball team here? A, B, D, E. So A plus B plus B plus E. There are 18 players in the basketball team. Similarly, 25 are in the cricket team. So 25 are in the cricket team. That is, it denotes the letters B, C, E and F. 25 and 22 in the football team, that is D, E, F and G. 22 in the football team. Then 9 play basketball and cricket. 9 play basketball and cricket, that is B and E. That is just about visualizing it. 9 play. Then 10 play cricket and football. Cricket, football. 10 of them. 10 play cricket and football, that is E and F. Then 8 play football and basketball. 8 of them play football and basketball, so that is D plus E. And then finally we also have what? Find the number of players, given that 4 players of the group play all the 3 games. So E is that set which belongs to football, basketball as well as cricket. So once this diagram is set and done for you, the rest of the job is finished. Good morning, Manang. So now you see, once this diagram is done, I'll do it directly here. Exams, of course, don't do it like that, but that's fine. So from here, what can we have? In that case, see, I'll do it directly. D value, just to save some time. D will be what? E is 4. So D value will be 8 minus E. So that's going to be 8 minus 4. 4. I guess you can get that, right? Like, just to save some time. Here, F. F will be 10 minus value of E is 4. So F will be 10 minus 4, that's going to be 6. And what will be the value of B? Here B will be 9 minus 4, that's going to be 5, straight away. So if you wish, we can note down the values also. That is like B is, 5, F is 6, and D is 4. That will help us. So you should have a bigger diagram and a clear diagram so that it doesn't get too confusing. Then from here we can easily find out the value of A. I'm not solving all of that in detail, okay? So straight away, so in the exams, when you solve, you can take out the equations one by one and then simplify and solve. I'm just trying to save some time, straight away getting to the point. Now, as it is given here, all the elements, 18. Now we already know the 3 elements, 5, 4 and 4. So what will be the value of A? The value of A here will be 18 minus 5 minus 4 minus 4. So that's how much is that going to be? That is going to be 5. isn't it? Because 5, 5, 10, 4, 4, 18. From here again, so this is already 5. G. And from here C. This total value was 25. So C will be 25 minus 6 plus 4, 10 plus 5, 15. So 25 minus 15, value of C will be 10. I hope you're getting my point here. And from here we will get the value of G. This whole value was 22. So 22 minus 6 plus 4, 10 plus 14. So I think that's going to be 8. So the value of G, I believe, will be 8. Alright, so as I said, I've just done it directly. Exam, you can take out, when you practice, you can take out the equation step by step, and then you can go slow also. Slowly you can solve. Okay, alright. Now the question is, total number of players in the group. How to find the total number of players in the group. So number one, total number of players in the group. That's why I'm just trying to save some time, so I'm going straight to the point. Total number of players in the group. This is the group. So total players A plus C plus A, B, C, D, E, F, G. So this total number of players in the group, how much will that be? You can just add them up and then see. Total number of players in the group, of course, is 42. If you just add them up. Second point, number of players who play cricket only. Where is cricket? Okay. This is the region which plays only cricket, this part. So that is C. That is how many? 10. So there are 10 people who play only cricket. Last one. Number of players who play only football. Last one, only football, this one. So this is completed by G. So G, 8. Alright, so that's how it is to be done. So there is no complicated calculations to be done at all. It's kind of simple. We have one more question which we will be solving. So that time again we will try to solve. Alright, number 2. A. A college awarded 38 medals in football, 15 in basketball, 20 in cricket. If these medals went to a total of 58 men and only 3 men get all medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? For this, of course, we may not necessarily need the Venn diagram, but I'll just draw so that you can just get the concept behind that. Again, football, basketball, cricket. Just naming the bounded regions A, B, C, D, E, F, and G. So as per the question, what happens is, I'm just doing it directly here. Okay, let F, B, C, denote the set. Denote the set of people getting medals in football, basketball, and cricket. So this one, I will do it directly, that is, the college awarded 38 medals in football, so that we can learn one more new formula, theorem. That's why I'll be doing it by another method, okay? The college awarded 38 medals in football. So, what probability? College awarded 38 medals in football. So, football, 38 medals. Basketball. How many? Basketball? 15 medals. Cricket, 20 medals. And it also says that if this went to a total of 58 men, F union B union C, 58 men, and only 3 get medals in all the 3 sports, intersection B, intersection C. These are very easy to predict. How many received medals in exactly 2 of the 3 sports? How many received medals in exactly 2 of the 3 sports means D, exactly 2, D and F, because B and E, if you combine, E actually has received medal in all the 3. So in exactly 2 sports, the people getting medals are this B, football and basketball. Now D, that is football and cricket, and F, that is basketball and cricket. D, B, D and F. That these are the values which we have to find out, the region I mean. Okay, that's why I drew that figure, so that we can really understand what is going to happen. So now what we can do is, we will be using the addition theorem and find out a particular value. That is, look here, we know this is one theorem. It can be, the addition theorem, as we know, can be extended to more than 2-3 sets also. So that is, A union B union C is equal to what? A union B union C. F union B union C will be F B C, I'll continue here, minus F intersection B minus F into B intersection C. I have to rub this off. Minus FB BC F intersection C minus F intersection B intersection C. This is the addition theorem. The same type of theorem which we had for, of course this is plus, the same type of theorem which we had for 2 sets. It can be actually extended to 3 sets also. So can you just put down the values and find out the solution and see what do you have? What value do you get? Some of the values that you know. So this value is how much? Union B, union C. 58. 38. 15. 20. This value. 3. Minus. I'll just take minus common for these 3 elements. That is F intersection B plus B intersection C plus F intersection C. So we just calculate these values. What do we have? We just simplify up and down. I'm doing straight. Plus B intersection C, F intersection C, that will be this value minus 58. So that if you calculate, I guess you will be getting 76 minus 58. So this value will be 18. So this value is 18. Now, if you're done, what is this value? So this value is 18. That means what is this? F intersection B. F intersection B. Right. Next is B intersection C. And next is F intersection C. These are the values. So from the boundary region, it is clear that F intersection B represents B plus E. B intersection C represents E plus F. and F intersection C represents D plus E. It can be done in many ways, okay? Now, what I need to find out was how many players were there who played exactly two, who received medals in exactly two of the sports. That is, I needed B, D, and G. No problem. E plus E plus E. That is 3E. So 18 minus 3 times of E. I'm just uh, taking it out to the other side. Simple calculation, so let's just do it quickly, but so then in that case, the number of people, 18 minus 3 into 3, 3 3s are 9, 9. So number of people who are getting medals in exactly two of the three sports will be 9. Alright, so that's the solution to it. Let's go quickly to the second one. In the meantime, I'll draw the figure, you can note down. Let's move on quickly to number B. This time I'll draw a bigger diagram. So this time what do we have here? Okay, that's good. A, B and C only. So that's much more comfortable. And the boundary regions A, B, C, D, E, F and G. Let's get straight to the point. So I believe you can write down as I had written for the first question, number B, that is I'll just dictate, okay? You just write down. I mean, we can leave it, you can leave some space for that also. You can later on write down also, no? Just like we wrote for question number 1B, the second set, that is, let A, B and C denote the set of people who like products A, B and C respectively. And right, I repeat once again, let A, B and C, A, B and C denote the set of people who like the products A, product B and product C. And A, B, C, D, E, F and G denote the elements in the bounded region bus. Alright, let's get straight to the point. 21 people like product A. These days even the chalks are of really bad quality. Twenty-one people like product A. 21 people like product A. So A plus B plus D plus E. 21. 26 like product B. B plus C plus E plus F. 26. Product C. 29. D plus E plus F plus G. 29. Fine. 14 like A and B. Sometimes you have to be careful, okay? They will mumble and jumble and then give you. So you have to be very careful with the system. It has to be in a systematic order. Okay, 14 people like product A and B. That is B plus E. We have 14 people. 12 people like product A and C. C, that's why. A and C. 12 people. B plus E. And 14 people like B and C. 14 people like products B and C. And 8 people like all the 3 products. And 8 people like all the 3 products. Alright, so from here let's find out directly. F will be what? E value we already know now, 18. So F value will be 14 minus, I guess you can do that, isn't it? So 14 minus 8, 6. From here we can find out the value of D, that is 12 minus 8, 4. Here we can get the value of B, that is 14 minus 8, again 6. So we have the values here. B value is, this is 8, B value is 6, D value is 4, F value is 6. This value total was 21. So from there we will get the value of A, that is 21 minus 6 plus 4, 10 plus 4, 18, 19, 20, 21, that's 3. I'm doing it directly. I believe class 11 standard you should not be having problems with these simple calculations. C value will be how much? 26. So 26 minus 6 plus 6, 12, 12 plus 8, 20 minus 26. So C value is 6. And the value of G, 29 minus 6, 10, 18. So So G value is 11. So the question is, find how many like product C only. Excuse me. So the solution to the question will be, find how many people like product C only. So I'll just write people who like product C only, that is G. So G was how much? 11. So that's it. So these are the only people who like only product C. No problemo. Alright. Okay, so now we'll move to question number 5, because question number 3 and 4 are from binomial expansion, binomial theorem. These chapters are reduced for this year's syllabus, so these chapters are not there in this year's course. So we'll have to skip those questions. We'll have to go to question number 5. But again, in question number 5 also, the first question, number A, that is from the arithmetic progression. So that even that part is also from the reduced or the revised syllabus, deleted syllabus. So that also will be skipped. We'll be going to the second one. So this actually I've already done in the chapter of combinations, so you can always go and check out those. All the link will be provided to you below later on. Anyway, let's go straight to the solution, that is number 5b. If A and G be the arithmetic mean and geometric mean respectively between two positive numbers, let A and B be the two positive numbers. So it's given that arithmetic mean between A and B is A. So that is A plus B divided by 2 is equal to A. Alright, we might need that. Also, geometric mean between A and B is given G. That is, root over of A into B is G. Alright, we might also need that. Now what are we supposed to do is that prove that the numbers A and B are also denoted in the form of A plus or minus root over of A plus G, A minus G. Prove that the numbers A and B are also represented in another way, A in this form. That means we have to solve this and then find that the two numbers from this term, that the two numbers are nothing but A and B. That means this is just another representation. That means these two are same only. That means A and B, the two numbers, two positive numbers, are represented in this format also. That's what we are supposed to prove. So now there is only one option. We have to solve this. We have to solve this and then see whether we get A and B or not, the two numbers. So let's solve. So let's substitute the values directly. A value, that is A plus B divided by 2, plus or minus this A plus B into A minus B. I'll just use the formula first. A square minus B square. So simplifying further now. This is just about simplification. It's a very simple question. So that's A plus B divided by 2 whole square minus G root of AB whole square. So that's A plus B divided by 2 plus minus A plus B. I'll just expand directly now. A plus B whole square, that's A square plus 2AB plus B square, all divided by 4 as the common LCM. This is root over done, so that's going to be minus 4AB. I guess that is understood. Good morning, each and every one of you. Tamsumanna, Noshibunna, and definitely not Mr. Beast. Okay, all of you, good morning. Those who have not subscribed to this channel, please Do subscribe also, okay, because so that you will get notifications regularly. And if you really appreciate, then please do like the videos. Give me a like also. Alright, I think this is done. I'm rubbing it off. I'll go to the solution part now. So that's a plus b divided by 2 plus or minus this one. That's going to be a square minus 2ab plus b square divided by 4. So further simplifying this, a plus b divided by 2 plus or minus root over of a minus b divided by 2 whole square. I guess that's simple. So that is going to be a plus b divided by 2 plus or minus a minus b divided by 2. एक लाइक तो बनता है ना, isn't it? अरे एक लाइक और सब्सक्रिप्शन तो बनता है तो ना. Alright, so this is what we get. So now we'll solve. So now either a plus b by 2, I'm just kidding, okay, as long as it's all up to you, as long as you learn, that's the only motive. So if you learn, that's good. But if you're learning, at least one like to banta hai again. A plus b plus a minus b, so cancelling, so we have 2a by 2 divided equal to a, or the other value, that is a plus b divided by 2 minus a minus b divided by 2, and that's 2a plus b minus a minus plus b a, so we have 2b by 2, so we have b. So you can see that both the numbers after even, so the equation here looks a little bit different, but what they're saying is that okay, you have two numbers, you have the arithmetic mean, you have the geometric means. So using this term, you just have to check or prove that these two terms also represent those two numbers only, or the other form of the two numbers. So that's what we are supposed to do. So we started with that solution, and ultimately we get either it's that value is equal to a, or either that value is equal to b. So these are the same two numbers, a and b only. So if you reverse back, we go back to the equation. So just the other forms, no other ways of representing the numbers. So that's it. Alright, that's a simple question. Alright, okay. Now, after that, again, going back to question number 6. Going forward, not back. To question number 6, number A also again is of the revised syllabus. Okay, number A is also of the revised syllabus for this year's NBSE. So we'll be going to number B. So we'll be moving on to number B, that is the sum of the first three terms of a GP. The sum of the first three terms, let A be the first term and D be the R be the common ratio. That I guess all of you now know how to write, because I've already done videos on that. You can always check out the previous videos also. I'll go straight to the point. The sum of the first three terms, that means a1 plus a2 plus a3, the sum of the first three terms is 16. So general term, okay, just a revision, general term, an at geometric progression, if you remember, that is a r power n minus 1. So using that, so a1 will be simply a, of course, first term, a2 ar, a3 ar square is equal to 16. Those who still haven't gone through the previous videos, please go through. It's all explained and all done, okay, all the exercises are done, so you can go and check out those videos. So a1 plus r square is equal to 16. Let it be, we might need that. Second condition is the sum of the next three terms, and sum of the next three terms, 1, 2, 3, the next three terms, 4, 5, 6. Next three terms is 128. So next three terms, that's going to be AR cube, AR power 4. Using that formula, AR power 5 is equal to 128. So if you can simplify this, AR cube common. So 1 plus R square, 128. Now, A into 1 plus R square. This is 16. So this can be written as 16R cube equal to 128. This is using 1. So I'll continue here. Okay. So R cube will be 128 by 16. So R cube will be 8, 6, 48, 4, 11, 8 times. So R will be cube root of 8. Alright, that's it, equal to 2. So that's it, job done. Now what will be the value of A? So now from 1, A equal to 1 plus R square 4, that is equal to 16. So A equal to 16 by 4, 5, 6, 7. So the value of A is 16 by 7. So that's what the question wants us to find out. Determine the first term, 16 by 7, common ratio 2, and also the sum to n terms of the GP. And also the sum to n terms of the GP. No problem. So here what we have is the value of R is 2, that is greater than 1. First term is 16 by 7. So sum to n terms, we will be using the formula A into R power n minus 1 divided by R minus 1, if you remember, because R is greater than 1. So that will give us A value 16 by 7. R value 2 power n minus 1 divided by 2 minus 1. So that's ultimately 16 by 7, 2 power n minus 1. That's the solution. We'll go to now question number 7. So that's about the conic sections. So conic sections, circles we have done. The rest of the questions will be uploaded very soon. Alright, question number 7. Find the equation of the circle that passes through the point 4, 1, 6, 5 and whose center is on the line 4x plus y equal to 16. Alright, as I said, I think in that video I have done using the standard form, if I'm not mistaken. This time I'll try by using maybe the general form. Let the equation of the circle be this. So let the equation of the circle be this. This is the general form. That again, this also the videos are uploaded. You can always go and check out. It's given that the point circle passes through the points 4, 1 and 6, 5. So I'm going straight to the point. The circle, all the chalk are no. The circle passes through the point 4, 1 and 6, 5. So question 1 implies, I'll do directly 4 square, 16 plus 1 square. That means that this point will satisfy this equation of the circle. This point will also satisfy the equation of the circle. So one by one we'll be doing. So I'll first start with 4, 1. So 16 plus 1, that is, as I said again, all these things are discussed in detail in the, you are coming here with at least some knowledge of the previous topics. If not, you can check out the videos which are uploaded also. 2 4s are 8g plus 2 1s are 2f plus c equal to 0. So we get that equation 8g plus 2f plus c plus 17 is equal to 0. This would be my equation 2. Again, what do? Our job is to find out the values of g, f and c, because these are the values which will give us the center. No? Second equation, the point satisfying this equation, 6 square again, 36, 5 square, 25, 2 6 are 12g, 2 5s are 10f, plus c equal to 0, again simplifying, that is 12g plus 10f plus c plus 11, 1, 3, 4, 5, 6, 61 equal to 0. Now how you simplify, how you solve, that's completely up to you. So now, before I really proceed, what I will do is, I will subtract equation 2 from 3. I will subtract equation 2 from 3. So that will be, I'll do it directly again, 12 minus, I'm just trying to save some time, please bear with me. 10, this is 2. 8f, c minus c, done. We have only now 2 variables left. 61 minus 17. So 61 minus 17, that's going to be 44, is equal to 0. That's going to be equation 4. Alright, done? Now the other information that is given is that, given that the center minus g minus f. Why minus g minus f? Because I'm using the general form of the equation of the circle. That's why minus g and minus f. Standard form you use, that's what? H and k, isn't it? So given that the center, what? Is on the line, lies on the line, 4x plus y is equal to 16. So that implies 4 of minus g plus minus f is equal to 16, minus 4g minus f is equal to 16. So now that will be up to us now to simplify. So that's our equation 5. It's up to you how to simplify. The simplification, as I say, can be done in your own ways. So if we just simplify, okay, let me put this as equation 5. So now what I can do is, I'll just add equation 4 and 5. So that will give me 4g plus 8f plus 44 plus minus 4g plus minus f. Just a moment. I'll just write this as 4g minus f minus 16 so that there is not a big confusion. So same thing I'll do. I'll just arrange the equation only. 4g plus 8f plus 44 addition, so minus 4g minus f minus 16 is equal to 0. So 4g, 8, 7f, 44, 16. 44 and 16, how much will that be? 44 minus 16, that's going to be, I guess, 28 if I'm not mistaken, equal to 0. So f equal to minus 28 divided by 7, I'm doing straight, minus 4. So the value of f that we have here is minus 4. So now we'll substitute that in one of the equations and get the value of g. And then again go back to the equation and get c. So from equation 5, I'll use minus 4g minus f value minus 4 minus 16 equal to 0. So that's minus 4g plus 4 minus 16 is equal to 0. Minus 4g minus 12 equal to 0. 31 between 16. So g equal to 12 by minus 4. So the g value we have here as minus 3. So then from maybe in one of the equations, let's say equation 2. So what was equation 2 for us? Equation 2 was 8g plus 2f plus c plus 11, I guess, 11 or 17, 17 plus 17 is equal to 0. So from here we can find out the value of c. So that's 8 into minus 3 plus 2 into minus 4 plus c plus 17 is equal to 0. So that's 24 minus 8 plus c plus 17 is equal to 0. So in that case, c, how much will that be? 24, 8 minus 17. So that's going to be, I guess, minus 15 is equal to 0. So the value of c is how much? 15, if I'm not mistaken. So the value of c is 15. Alright, so we have all the required values. Now we can go and get the equation of the circle. Therefore, required equation of the circle is, I'll write again, x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So that's x squared plus y squared plus 2g. What was the value of g? Minus 3. X plus 2f y plus c, 15 is equal to 0. So we have our equation. I'll rub it up. So we have our equation, that is x squared plus y squared minus 6x minus 8y plus 15 is equal to 0. So that's the equation of the required circle. Alright, okay, let's go to the second part. Now this is about an ellipse. You can always follow us on the Instagram page also, send tutorials where some of the formulas are already uploaded. I'm not getting sufficient time, I'm having some difficulties, so that's why I'm not able to upload the formula sheets regularly. So but very soon all those will be uploaded again, so from there also you can get those formulas that we have. Okay, all right, question number 7. Number B, find the coordinates and foci on the vertices, the lengths of major axis and minor axis. Very simple question. The eccentricity, the length of the lattice rectum of the ellipse. Given ellipse, x squared by 4 plus y squared by 25 is equal to 1, which can be again written in the form of x squared plus 2 squared y squared by 5 squared is equal to 1. Now since for an ellipse, A always has to be greater than B, so here A is 5 and B is 2. I'll just write it in detail for you. So the ellipse is of the form, because see, for an ellipse the value of a always has to be bigger no matter what, so that means a has to be 5 and b will be now 2. So that means this ellipse is of the form x square by b square plus y square by a square is equal to 1, which is a vertical ellipse now. So that means our ellipse is a vertical ellipse that we have. So its major axis will be given by the y-axis, minor axis will be given by the x-axis. Its focus will lie on the y-axis, vertices will also lie on the y-axis. Why? Because this represents vertical ellipse. Alright, is this done? This is a square. So now since things are sorted out, let's find out the value of c. And the value of c, of course, will be simply root over of a square minus b square. So that's root over of 5 square, 25 minus 2 square, 4. So the value of c is 21, root over of 21. Alright, let's jump now. Coordinates of the foci. So coordinates of the foci is 0 plus minus c, because the focus now will lie on the y-axis. So that is 0 plus minus root over of 21. That's the coordinate of the foci. Next is the vertices. So here also the vertices will be on the y-axis, 0 plus minus a. So that is 0 plus minus 5. Length of the major axis. Length of major axis. Length of this is the major axis for a vertical ellipse. So this is a plus a, because the vertices are 0 minus a and 0a. So it's a plus a. So that's going to be 2a. That's 2 into 5. That is 10 units. Similarly, length of, it's all about identifying your ellipse. The rest is very simple. Length of minor axis. For minor axis, the vertices is b0 minus b0. So b. So that's going to be twice of b. So that's twice into 2, 4 units. Eccentricity. Eccentricity is given by c by a. What was the value of c for us? Root over of 21. Divided by a, the value of a was 5. So eccentricity is root over of 21 by 5. And then finally, length of lattice rectum. Length of lattice rectum will be 2b square by a. So that's like 2 into b square. B value was 2. So, okay, I'll just write by a. So 2 to the 4, 4 to the 8. 8 upon 5. Alright, so today we will not be able to finish the entire set of the questions, so maybe tomorrow, because I have to go back to the school again. So I have to run back to the school again. So I have done whatever I could within the limited space of time that I had. So we have round about, I guess, maybe another 3 or 4 odd questions left. So that also will be done. Maybe by tomorrow we will be able to do that. Yeah, definitely by tomorrow we will be able to do that. So, alright then, I hope that you have learned. Do practice at home, do study well. And very soon I'll be finishing up this question, and then of course I'll be uploading the other part of the circles also. Alright, so till then, study well. Have a good day, all of you. See you very soon again. So, have a good day, all of you. Take care, okay? Bye bye.